Every one of your customers' records is sitting in the same table, same database, same disk, their rows interleaved with each other, separated by one column. And the only thing standing between customer A and customer B's data is that every single query anyone on your team ever writes remembers to say where tenant ID equals this one. Forget it once in one endpoint, and A sees B's invoices. That is not a bug you fix on Monday. That is a breach you disclose to your customer and probably to a regulator. This series builds a platform where that is impossible rather than merely unlikely. And it starts by admitting that the way most of us do it is not a security model at all. Here is what it actually looks like. This is not sloppy code. It is parameterized, it is indexed, it reads well, and it would sail through review, because everything in it is correct. The problem is what is not there. There is no tenant filter, and the endpoint it lives in was written by someone who was thinking about invoices, not tenancy, at 5 on a Thursday. Now look at what happens when it runs. It does not error, it does not warn. It returns rows, more rows than it should, and the API happily serializes them into somebody's browser. The failure mode of a missing where clause is a successful response. So the obvious answer is, remember the clause. Write it down, put it in the onboarding doc, catch it in review. And that fails reliably for reasons that have nothing to do with how good your team is. It is not one query. It is every query in every endpoint, plus the reporting job, plus the admin tool, plus the one-off migration script someone runs at midnight, forever, including the ones written by whoever joins next year. You need to be right every single time. An attacker, or just bad luck, needs you to be wrong once. And the thing that makes it genuinely dangerous is that the mistake is invisible. A reviewer sees correct SQL. Nothing on the screen marks the absence of a line that should have been there. It is worth being precise about why this class of bug is different, because engineers tend to file it next to every other defect. Most bugs cost you a fix and an apology. This one is unrecoverable in a specific way. Once customer A has seen customer B's data, you cannot unsee it. There is no rollback. You have to tell customer B that their information was shown to a competitor, and you have to tell them how long it was happening, which means going back through logs that were never designed to answer that question. Meanwhile, every enterprise deal in your pipeline has a security questionnaire that asks how tenants are isolated. The honest answer, if you are relying on convention, is by everyone remembering. Nobody signs that. So here is the shift this whole series is built on. Stop asking every query to be correct and make the wrong query impossible instead. Move isolation out of the application, where it depends on human memory, and into the engine, where it is enforced whether you remember or not. The database already knows how to refuse things. It refuses to violate a foreign key. It refuses a duplicate primary key. Nobody writes a code review checklist for uniqueness, because uniqueness is not a convention, it is a constraint. Tenant isolation can work the same way. Then that query I showed you, the one with no tenant filter, stops being a breach and starts being a query that quietly returns nothing it should not. Before we can make the database enforce anything though, there is a decision underneath all of it. Whether your tenants even share a database. Separate database per customer is the safest thing you can build, and it will bankrupt you at a few thousand of them. Next episode, silo, pool, and bridge, and how to choose without lying to yourself about the cost. See you there.